Hello, good evening. Hello, good evening. All right. So, this is our first tuition. Uh, for February and March, our my tuition will be totally free. You don't need to pay anything. If you want to get the notes, you can get it by fill in the Google form. So I will send the link for the Google form for you. All right. If you are not in my group, my tuition group, I mean, wait, I'm finding. Okay, here. And then there is my. Let me write something first. All right. So fill in the form if you want to get the the notes for free. Okay, and then this is my Telegram group, where some of you might need it. Even you are not in my WhatsApp group, you also can ask questions, right? This is my Telegram group. My Telegram group. Okay. Now, if you got any question you want to ask, you can straight away type there. So in YouTube here, YouTube Live, it might be not let. It is like lagging for delay for like 5 seconds like that. Okay, but no problem. First of all, I want to teach you how to use your how to use. Okay, like now I'm clicking my on tuition that one. Okay, here. Now, first of all, if you feel like it is not clear, right, not clear here, now you can click this, right here, the quality. You can change the quality by other. So my one is using auto. If you think like, hey teacher, why my one is so blur? So you can click this one or this one or this one, because I don't know your resolution, right? So if you think it is blur, you can change to other resolution that is suit you. Okay, my one I'm using auto, so my one is using HD, this one, right? Okay, this is what we have. Wait, okay. All right. Now this is the first thing. The second thing that I want to tell you is how to use my notes. So this is the notes. If you don't print it out, it is okay, because at the end of the chapter, I will send the notes with full answer to you in a letter. All right, now not yet. All right, but I will update my notes in my group lah. Now, first of all, if you want to use it, all right, you can just click here. So you will go to chapter 1.1. All right, you can click here. All right, so if like you want to do 1.2, so you just click here. So it will go to 1.2. All right, 1.2, page 49 here. So it will direct you to there. All right, so very easy to use. If you don't print it out, it is okay. All right. So okay, so let's start our tuition. All right. The next thing is February and March, it is free. It is free, and you can invite your friend to join. All right, totally free one. This is open to public one. Now, and then the second thing is, if you want the notes, you have to fill in the Google form. All right, and you join. I will invite you into my Telegram. I will invite you into my WhatsApp group, and then I will send you the notes. right? And then normally my class will start at 7:30, but before 7:30, like I'll send the link like 7:20 like that. Okay. Now, this is the timetable for I mean, wait you fill in the form, you should know. Some of you still asking me, teacher, the Mandarin one when? The Mandarin one will be on Thursday. Right? Form 5 Mandarin version will be on Thursday. Right? This is the this is the timetable. So this is timetable. Monday is Form 5 English 7:30 to 9:30. So Tuesday Form 4, Wednesday Form 4 Mandarin version English version 7:30 to 9:30 lah all. And then Thursday Form 5 one Mandarin version. So it is 7:30 to 9:30. So this is my timetable. Alright. If you want the Mandarin version, you can go to see. Alright. To see me on Thursday. The content will be the same. And then the next thing is, if you want to watch the replay, you just click the link that I sent. Right? It is the same one. Alright, so you can just watch the replay. So now the last thing that before we start our class is, now this year most probably your exam in SPM will be earlier. Right? Not in January, not in December. So it will be earlier. So they will pull it back earlier. So this year I will teach slightly faster. Okay. Now, all right. So we can start already. So we go to chapter 1, force and motion 2. Right. I believe you have learned force and motion 1 in Form 4 already. So force. First of all, chapter 1.1, it is resultant force. So what is resultant force? So this one you need to memorize. This one need to memorize. So single force that represent the vector sum of 2 or more forces acting on an object. Okay, so it can be many force, right? 2, 3, 4, but normally in Form 5 it is just 2. So now, so you can have this one and this one. You got one force pulling here, you got one force pulling here. So this one, resultant force is 0. When resultant force it is equal to 0, we call it as equilibrium. Alright. So when equilibrium, you need to know what is the keyword. So stationary, not moving, or moving with constant velocity. All of these are equilibrium. Right? Or the resultant force equal to 0. Mean the left force and the right force will be the same. Okay. Now, resultant force is equal to 0. So the object will be sorry. The resultant force. My force is not spelling correctly. Alright, but never mind. I guess you are okay. So the resultant force, it is not equal to 0. Mean here it is 15, here it is 10. So it is not 0. So this one 10 minus 10, it is 0, right? So this one is not equal to 0. So when not equal to 0, it will accelerate. So the force go to the right is more than the force go to the left. So it will accelerate to the right. Wait, some student cannot join. Right, wait. Here. Wait, wait, give me 1 minute. Cannot. Alright. So, okay. Now, if the force to the left more than the force go to the right, so this is resultant force is not equal to 0 also, right? So this one will accelerate. So they will accelerate to the left hand side because this one it is stronger. My link cannot be open. Wait, Some student asking me why cannot join. Huh? Impossible that cannot join. Huh? Why I click the link I can join? The video is not. Wait. Why cannot? The video is restricted. Please check the Google Workshop. Huh? Since when I restrict it? Alright. Give me 1 minute. I go and check. No, it's made from. Okay. Try again. You guys try again. If cannot join, you tell me again. Alright. The first tuition, sometimes it is like that. Okay. Now can already. Alright, but never mind. I continue. So the formula that we gotta use is when okay. Why cannot join? I don't understand why cannot join. I don't know why cannot join. Okay. Alright. Okay. Now, okay, never mind. Leave it first. Now, we continue from here. So, the formula that we gotta use is F is equal to MA. F is equal to MA. F is force, right? F is resultant force, right? Resultant force. M is mass of the object. The unit will be in kg, right? Force unit will be in Newton. And acceleration A is equal to the unit is ms negative 2. Alright. So now we are going to see there is 4 situations that we gotta use. Alright. Situation 1, 2, and 3, and 4. 4 situations. So 1 and 2 is very easy. So 1 and 2 is situation 1. If the force here pushing here and pulling here, so the direction it is the same. The direction both are going to the right. The direction it is the same direction, you just press them. So what is the resultant force? 10 plus 5, 10 plus 5. So your resultant force will be equal to 15 Newton. You just plus them, right? Now, what if the situation 2, the direction it is not the same? Mean one go to the left, the other one go to the right. So one go to the right, it is 15. The other one go to the left, it is 10. So 15 minus 10, it is 5. So you minus. If opposite direction, you just minus, right? Now, situation number 3. Situation number 3. So the first one, it is going right angle with another one, perpendicular to another one. So when the force is perpendicular to another one, so you need to use Pythagoras theorem. We are going to see later how to do it. Okay, meaning that you pull here 4 Newton, I pull here 3 Newton, so it will go into this way, 5 Newton. Okay, right, Pythagoras theorem telling me it is going that way. Now, situation number 4. Situation number 4, it is not right angle, so it is other angle. So when it is other angle, when I pull here 15, you pull here 10, so it is not perpendicular, so you need to use cos rule or sine rule. Right? When you use cos rule or sine rule, I will teach you in the future how to use the cos rule and sine rule. Okay? Now, not definitely not today lah. See whether I can reach here or not. So we go to the first example. All right, first example. Example number 1. So I got 2 kg object. So I pull to the left with 10 Newton. You pull to the right with 15 Newton. So it is opposite direction. So when opposite direction, so now F is equal to MA. Right? The formula F is equal to MA. So what are they asking you? They are asking you what is the acceleration, right? Find the acceleration of the object. So F, I need the resultant force. Resultant force is minus 15 minus 10. Right? 15 minus 10 is equal to MA. M, mass of the object, 2. A, I don't know. So I can find A. A is 5 divided by 2. So A is 2.5. The unit is acceleration is ms negative 2. Right, ms negative 2. So F is equal to MA. Okay, F is equal to MA. Now you need to be careful here because here it is smooth surface. What is smooth surface? Smooth surface is no friction. There is no friction. Right, smooth surface. If they don't tell you whether this one it is smooth surface or not smooth surface, we are going to see later, like the question like telling you this is rough surface, or they don't tell you, so they will give you this one frictional force how much, or they will ask you how to calculate the frictional force. So if they tell you this one is smooth surface, mean the frictional force it is 0, right? No friction, right? No friction mean the frictional force is equal to 0. Okay, now we see the second example. The force go to the right is 15, go to the left it is 10. So opposite we minus. Opposite we minus. So now what's the formula? F is equal to MA. F is equal to MA. F is 15 minus 10. Is equal to MA. M is 5. A, I don't know. So 5 divided by 5. A is 1. Acceleration ms negative 2. Okay. Now, hence, relate the mass with the acceleration. So we can see this one 15, 10. This one 15, 10. So this is the mass. This is the mass. This mass is 2 kg. This mass it is 5 kg. So when F is equal to MA, now your force it is the same. Alright, both force it is the same. This one is constant. So when the bigger the force, bigger the mass it is bigger. Right, when the mass it is bigger, right, the acceleration it is smaller. Right, bigger the mass, acceleration is smaller. So the greater the mass, you see the mass when it is 5, it is 1 only. It accelerates very slow, right? But when the object it is light, the acceleration it is big. So relate the relationship between the mass and acceleration. The greater the mass, the smaller the acceleration. Right? The bigger the mass, the smaller the acceleration. Right? Or the mass is inversely proportional to the acceleration also can, right? If we got graph, we will use inversely proportional, but here we don't have graph, so we will just say this one bigger, this one smaller. All right. Now, here we are going to do example number 3. So here we got 10 Newton. Here we got a force that we don't know how much. This is F, unknown. All right. Now, find the value of the F if the 3 kg object is accelerate with the acceleration 2. Now, so of course you don't know where will it accelerate, right? So this answer is actually not so right. But never mind, we are going to do both. So it can be accelerate to this side with 2. Or it will accelerate to this side too. So I don't know which one. So if I said it will accelerate to the right, mean the F must be bigger than 10. Because if less than 10, it will not accelerate to the right. Okay? Now, if I said accelerate to the left, mean 10 is greater than F. Meaning that, of course, you tell 10 here, 2. Where will it accelerate? So it will accelerate to the left. But if this one is like 15, here 10, where will it go? 10 Newton. It will go to the right. So now I don't know this one it is go to the left or right. So I will do both. Alright. If the 3 kg object is accelerating to the left, alright. So I do both. Mean left is bigger. Alright. So 10 is bigger. So bigger minus smaller is equal to MA. So F is equal to MA. F is 10 minus F. 10 minus F. This F is not this F. This F is resultant force. Alright, 10 minus F is equal to MA. M is 3. A is 2. Right, 2. Here 2. So now I am going to bring 10 minus F is equal to 6. Alright. So I'm going to bring this negative F into here. This side. This negative F bring to here become positive F. So this one positive bring to here, it is become minus 10 minus 6. So 10 minus 6, my F is equal to 4. So F is equal to 4 Newton. Wait. Okay. F is equal to 4 Newton. Alright. Meaning that here it is smaller. If this one accelerating to the left. What if the object is accelerating to the right? Okay. To the right. So if the 3 kg object is going to the right, mean the right hand side F is more than 10. Right? Bigger minus the smaller one. F minus 10. Right? F minus 10 is equal to MA. Right? So F is equal to MA. So the F minus 10 is equal to MA. M is 3 kg. A is 2 kg. 2. 3 multiplied by 2. So now F minus 10 is equal to 6. Right? So F is equal to 16 Newton. F is equal to 16 Newton. Is that alright? Meaning that if you do it mathematically, so this one you don't know the A is go to the left or go to the right. So actually go to the left, we call it as negative 2. Go to the right, it is positive 2. So normally we are going to do 2. 2. Modulus 2. Right? Mathematically. But now this is physics. I'm not going to make it so complicated. Alright? I'm not going to go for make it so complicated. So we just do it this way. Go to the left, this way. Right? Go to the right this way. Okay. Now, okay. So if go to the left, go to the right, you know already. Right? Go to the same direction, you plus it. Go to the opposite direction, you minus it. All right. What if go into this direction and this direction? So perpendicular, right? So when you see it is perpendicular, so A, the magnitude of the resultant force by help of the drawing. So now magnitude. So you need to draw. So when you need to draw, okay, A, we are going to draw it. So this one you are going to draw 3 Newton, you are going to use 3 cm. Alright, so you are going to draw 3 cm. Newton, you are going to draw 3 cm. Here 3 cm. Now 4 Newton, you are going to use 4 cm. 4 cm. So I don't measure. Alright, I don't measure. So this is right angle, you need to know. This is right angle. So you can use the scale drawing by this one 3 Newton, you can use 6 cm. At cm also can, no problem. So if they ask you to draw. So you are going to continue drawing by this way. Alright, so you continue this way. Meaning that this is 3 Newton. This is 4 Newton. So you draw another one parallel to here. It is 3 Newton and 4 Newton. So this one, it is your resultant force. Alright. So normally resultant force, we are going to write it into this way. F R. Alright. R stands for resultant. Alright, result. Right, result of the force. Resultant force. So magnitude of the resultant force by drawing. So if you draw it already, you got measure. Definitely you will find it as FRS 5 Newton. 5 cm. So you measure this one as 5 cm. So you will get 5 cm represent 5 Newton. Is that alright? Okay, this is how we draw it. Okay, direction of the force. So after you draw, you can measure this angle. You can measure this angle. This angle, it is 36.87. Right? But now, because of I don't measure, so I use calculation. So the calculation is, right, you got here, right? So we use tangent, right? I use calculation. Tangent theta tangent theta is equals to opposite over adjacent. Opposite is 3, adjacent is 4. So 3 over 4. Right? So I want to find theta. So how to find the theta? Theta, you need to 3 divided by 4. And then you need to shift tangent. Right? Calculator. Where's my calculator? Okay. 3 divided by 4. And then you shift tangent. You get 36.87. So you get 36.87. So theta gonna be 36.87 degree. So by calculation, you will get this. If you measure, right, this one normally they will ask you to measure. So when measure, you also will get this. Okay, but this one very rarely come up. Right, so I just tell you only. Right, just tell you. You don't need to go into detail into this one. right? Because no place can ask you about this one, right? Unless your monthly test can, right? And in SPM very hard to ask you this kind of question. So the next thing it is, they ask you acceleration of the object when the surface it is moved. So F is equal to ma. They want to find acceleration, so F is equal to ma. So the resultant force, we got it already. Resultant force, it is 5. M, it is 3. A, I don't know. Right? So A, it is 5 divided by 3. 5 divided by 3, you get 1.67. 5 divided by 3, you get 1.67. Unit is ms negative 2. Is that okay? Is that okay? I hope you're okay. So we go to the next kind of question. If you got any question want to ask me, you can just write into that one. Wait, give me 1 minute. You can write into the comment. I cannot see my comment right now because just now live. Okay. Yeah. You got any question? You can leave it in. You can comment there. I don't know how to change it back to my that one. But never mind. Okay. Next. So we do this kind of question. So you got one unknown force. Here it is a rough surface. Right? Rough surface mean you got friction. Here got friction. Frictional force. So what is the frictional force do? The frictional force always against the motion of your force, the motion of the object. So when you push here, so the frictional force stop you, don't let you move forward. If you are pushing here, so the frictional force will be in this side. The frictional force will change direction to against the force that you apply. Okay. All right. So now I got one F. So this one is the friction. Normally the frictional force, I will use this symbol mu, right? Mu. So for frictional force normally. Okay. So find the value of the F if 2 kg is moving with constant velocity. Constant velocity here very important, right? With 3 ms minus 1. So giving the frictional force is 10 Newton. So how to do this, right? So most of you will do this. F is equal to ma. Yeah, I know, cikgu. I know. F resultant force, force F minus the friction. Minus the friction. How much is the friction? Friction, it is 10. Is equal to ma. M, it is 2. A, it is 3. So, cikgu, this one 10 move to here. So F is equal to 16. F is 16. This answer is wrong. No. So I want you to see properly, right? Which is in the exam. Be very careful. This one is called constant velocity and this one is not acceleration. What is the unit of acceleration? Acceleration is ms negative 2, not 1. So this is not A. This A, no, salah. So constant velocity acceleration is equal to 0. You need to know. Constant velocity acceleration 0. So 2 times 0. So this one 2 times 0 is 0. 10 move to here. So your F gonna be 10 Newton. F is 10 Newton. Is that okay? Now, I want you to know one thing. When you do in any question, right? Any question. So, now, here frictional force, it is 10, right? You know, right? This question giving you already, rough surface, 10 Newton. So, now, when you see constant velocity mean equally equilibrium. Constant velocity mean equilibrium. Equilibrium mean left and right will be the same. So F gonna be 10 Newton. So you can just write your answer as 10 Newton. Left hand side and right hand side will be the same. Okay? When you see constant velocity, left and right will be the same. Right? But if you don't want, please substitute your acceleration as 0, but not 3. Okay? Be careful, huh? So next. Next question. So next question, we got here 20 Newton push on 2 kg object of the rough surface. So the acceleration of 2 kg object is given find the acceleration of the object. Given the frictional force, it is 10. Alright. So now here it is 10. And then this one, they want to find acceleration. So here 20, here 10. So you got a net force. You got a resultant force. Sometimes we can call it a net force also. Net force. So the resultant force is. So we apply to the formula. F is equal to ma. So what is the resultant force? Is 20 minus 10. Where is the 20 come from? 20 come from here. Where is the 10? 10 is rough surface. Rough surface, the frictional force here, they told me it is 10 Newton. So this is my resultant force. Resultant force is 20 minus 10. M, mass of the object, 2. A, I don't know. So A, I don't know. So 10. 20 minus 10 is 10. 10 divided 2, A is equal to 5. Acceleration, the unit is ms negative 2. Right? I hope you're okay. This is still easy. Okay. Now the next question. Now find the acceleration of 5 kg object given the frictional force. It is 5. Right? Frictional is 5. Now we got two forces acting on the object here. 30 Newton and 10 Newton. So this one, your resultant force is 30 minus 10 because they are opposite direction, right? But don't forget, you still got one more frictional force. Where is the frictional force acting? Because of this one, the resultant force is going to the right already. So your frictional force will be in this direction. So I'm going to draw the frictional force into this direction. Right? Frictional force, how much? 5. Frictional force, it is always against you. If, let's say, this is 30, this one is 30, here it is 40 pulling here. Alright, so where is your net force? Where is your resultant force? Your resultant force is going to this way. So where is your friction? The friction will change direction into here. 5 Newton. It will change the direction. Even it is same rough surface. Yeah, teacher, same question, same rough surface. The frictional force will change direction to against the resultant force. Alright, be very, very careful. So 30 minus 10 minus 5. So this is how you do it. F is equal to MA. So 30 minus 10 minus 5. Right? Right? 30 minus 10 minus 5 is equal to MA. M 5. A I don't know. So this is 15. 20 minus 15 left 5. 5 is equal to 5A. So A is equals to 1. Right? A is equal to 1. 30 minus 15. 30 minus 30, not 20. I'm sorry. 30. I'm sorry. My mistake. So this is 15. 15 divided by 5, it is 3. I'm sorry. My mistake. So 3. Yeah. Is that okay for you? 30 minus 10 minus 5. 30 minus 10 minus 5. 30 minus 15. Is that okay? So we go for example number 8. Example number 8. So you see this force and this force, they are same direction, but it is on the rough surface. Right? So find the acceleration of 5 kg object given the frictional force is 5. So how to do it? F net force is equal to MA. Right? What is your net force here? Net force is 30 minus 10. No, not minus, because they are same direction. So where is your frictional force right now? Where is the frictional force? Frictional force is 5 Newton. Yeah, I know. Where is the frictional force? The frictional force is against the net force, the resultant force. Your resultant force here is 10. Here is 20. So total 30 go to the right. So how much is the frictional force against it? So it is 5. So 20 plus 10 minus 5. This is how you get it. So again, what is that number? 20 and 10. Oh yeah, 20 plus 10 minus 5. This 5, it is your frictional force. Right? So MA. M is 5. A I don't know. So how much is this? 30 minus 5 is 25. 25 divided by 5, it is 5. A is equal to 5. ms negative 2. So this is what we have. Into which direction? Go to the right. Going to the right. Okay. Alright. So we continue from here. A 2 kg object is pulled with 15 and then it moves with constant velocity. Constant velocity. Be very, very careful. Constant velocity. So constant velocity 3. Constant velocity 3 or 5 or 2 or what? It is not important already. So when it is pulling, the pulling force increased to 25 right now. So what is the acceleration? Another word, this question want to ask you, how much is the frictional force? How much is the frictional force? How much is the frictional force? Here it is 15. Here, frictional force. Right? With constant velocity, it is excuse me. So here it is 15. Here again 15. I told you just now. Constant velocity. Right? Here 15. Here 15. Because it is equilibrium. Because it is in equilibrium. Okay? But never mind. I want to calculate. I'll show you how do I calculate. F is equal to MA. So what is the resultant force? 15 minus the friction. 15 minus friction. right, is equal to ma. M, it is 2. A, acceleration. Constant velocity acceleration is 0. So the negative friction bring to here become positive. 2 times 0 is 0. 15 here, move to here. So this one is 15 plus 15. 0 plus friction. So how much is the friction? 15. So next time I told you, just now I told you, no need to do. Alright, you don't need to do. When you see constant velocity, 15 here, 15 here. Right? But now you want to increase to 25. So the friction here become 25 already. Here become 25. But your friction still 15. Right? So you increase the force. Right? 25. Now your force, your friction still 15. Okay. So now F is equal to MA. F is equal to MA. F is 25 already. Minus friction. Friction is 15. Is equal to MA. M is 2. A I don't know. They are asking me how much is my acceleration. How much is the acceleration? So this one is 10. 10 divided 2. So A is 5. Okay. So the acceleration it is 5. Okay. So we are going to do some question later. But before we do the question, so I want to go to C. I want to show you a video that I made before, right? Wait, resultant force. Wait, I'm looking for the resultant force. Yeah. You can, I send the link into here. Cannot, how? Never mind, I show you. Okay. Okay, this is the the video that I made before, right? So we are going to see if there is what is frictional force, what is force. Frictional force in Mandarin is called 摩擦力啦. So this is rough surface, this is my table, this is rough surface. So I pull a string into here, right? So I tie the string with I stick it with the sellotape. So I pulled it. Then what happened? The this is calculator. The calculator can be moved, right? So now let's say the frictional force is 5 Newton. Let's say lah. So I pull 1 Newton, it is not going to move. The force applied is less than frictional force. Okay. Now see, the force applied 1 Newton, the frictional force 5 Newton. So will it move? No, it will not move. Right? So if I pull with 2 Newton, no. 3 Newton, no. 4 Newton, no. 5 Newton, then it start to move. Then when it start to move, you move with constant velocity. So meaning that it move with constant velocity. Move with constant velocity mean this friction is 5. Frictional force is 5 Newton. So how much is the force that I apply so that it can move with constant velocity? Of course, it is 5. Right? If I apply 1, then it will not move because the frictional pull it back with 5. I pull 2, I pull 3, I pull 4, it will not move. I pull 5, it will move with constant velocity. Right? So left and right will be the same when you see constant velocity, right? Now, what happens if I pull it like that? Okay, so it will move with constant velocity. Okay, if I pull it more than 5, right? Oh, so this one frictional force is 5 Newton. When you see any question, it is constant velocity, so it is the force applied is frictional force. Now, so if I pull more than here I force apply. So how much is the frictional force? 5. So I pull with 5, then it will move with constant velocity. Right. Okay. The frictional force will change direction one. So this is what I want to tell you. Right. So this is what I want to tell you. Another word here. So I pull with 15, it move with constant velocity. I pull with 15, it move with constant velocity. So what is the friction? 15 lah, no need to say. 15. Huh? Right. Do you understand it? Like just now? Where? Where is constant velocity? Just now I saw constant velocity. I push with a force. I don't know, but you tell me the frictional force is 10, right? The frictional force is 10, right? So how much is the force that I push it? So I have to be 10 so that it will move with constant velocity. If you push more than 10, then it will accelerate. Is that okay? Do you get it? I hope you can understand it. All right. Ah, yeah, before I tell you, so normally, I will let you rest for a little while at, because last year got student asking me, teacher, can, 2 hours so long, can rest for like 10 minutes, 5 minutes or not in between? Yeah, can. So, normally in my class, I will let you rest, like go to toilet for a little while, like at the first part that I teach, like at 15 to at 30 like that, we rest for a little while. So now, if you got my notes here, now you can try to do some question from here. Step paper from question number 20, from the page 7 to to here a lot to 16, 7 to 16. So we rest for 5 minutes, so I'll be right back. So if you don't want to rest, you can try to do some question from here, right? Page 7 until 15. If you want my notes, right, so you have to fill in the Google form. You fill in the Google form to get, right? So the Google form I already put into the chat there. Okay. All right. So, um, mm, I'll see you later. I got toilet for a while, so you can do the question from page 7 until 16. I'll be right back. Okay, I'm back. So we rest for 5 minutes already, so we continue. So diagram 13 shows a stationary object with force 1, 2, 3, and 4 are applied. So now which statement it is correct? Now they said stationary. Stationary mean 3 into this way, 4 into this way. 3 and 4 must be the same. Right? So this is the answer. So 1 is equals to 2. So stationary. 1 is equals to 2, not bigger and not smaller. Okay? So answer is A. Number 2. A constant force 35 pushed to here. So a block placed on the rough surface shown in the diagram 12. If the frictional force it is 5, the frictional force against it is 5, the block will move with acceleration. So it will be called constant acceleration, not acceleration only. So it is called constant acceleration. Okay, next one. Here, diagram 16 shows the two people that is pushing on the large box with the force 1, 2 respectively. Magnitude of the force 1 and 2 are the same. F1 and F2 it is the same. Then the box it is in equilibrium. So F1 and F2 is equal. So F1 is equals to F2. So you can bring it to here. F1 minus F2 is equal to 0. F1 minus F2 is equal to 0. Answer it is B. But mathematically, teacher, what if I bring this one to here? So F2, F1, F1 is equal to F2. I bring this one to here. This one also equal to 0. F2 minus F1 is equal to 0 also. But we normally take the right hand side as positive. So now we are going to take the answer as B. But mathematically, A also correct. Right? This question not so good. Right? Mathematically, A also correct, but answer is B. Wait. Alright, continue from here. Now, the diagram shows the force so small. I make it bigger. The diagram 12 shows the three forces acting on the object. Which of the following represent the magnitude and the direction of the resultant force? Okay. Now, here, left and right. So, left and right, you got 2 go to the left, and then you got 6 go to the right. So, we got a resultant force 4 go to the right. And then here got 3. Alright. So, here got 3. So, you need to draw Pythagoras theorem. Where will it go? It will go into this way. You go into this way. So this one 3, 4, 5. 5 Newton. So go to this direction with 5. Answer is B. Okay, the next one. Situation below shows a tug of war. So which situation produces 0 resultant force? So 800, 900, not 0. 900, 800, not 0. 800, 800, yes. 700, 750, no. So answer is C. Resultant force 0. So the diagram 17 shows a car apply a force F and move with uniform velocity. There, here, uniform velocity mean left and right will be the same. So what is the magnitude of the F? F is equal to frictional force. Equal to the frictional force. Answer is B. Left and right will be the same. Okay. This kind of question I haven't teach you yet. But never mind, we try to do it. Which diagram shows the sum of the force 6 Newton and 8 Newton? So now 6 Newton. So I am going to draw the first one for you. So 6 Newton up, 8 Newton go into this way. So this one, it is going left and then right. So you push here, I pull here, so it will come into here. This one is correct. So you see the direction of the force, it is going up this way. Yeah, A is correct. So you push here, I pull here, 10, 6. And then the direction should be going up, not going down. So if you draw it, you can draw it this way also. Impossible when you draw here, this one should be going up, follow. So impossible to go down one, right? Cannot be go down. It is going upward. Pythagoras theorem. So this one come to here, this one come to here. So when you draw here, it's supposed to go into this way. Alright, C also wrong. So this one going down, this one going right. Same as this one. Salah. Answer is A. Alright, you got question you can ask. Now, diagram 10 shows a force acting on the aeroplane which is moved forward with the acceleration. Move with acceleration mean forward it is stronger than backward. Right? Let's say this is 10. Let's say this is 2. Right? So the right is more than the left. Right? So the forward thrust is greater than the drag force. The forward thrust is more than the drag. Yeah, answer is C. Right? So, and then they said constant attitude. Constant attitude means it is horizontal, not going up or not going down. So up and down will be the same. So the lift force here is equals to the weight. So lift force is equals to the weight? No. Lift force is equals to weight? No. The drag is more than the forward? No. Answer is C. Answer is C. Now, which of the following is method to reduce the air friction? So, now, how to reduce the friction? Wearing the fit attire? Yes. Right. Now, if you are not wearing the fit attire, so the air from forward, right, become the friction. Okay. So wearing a helmet, wearing a glove, using the big size of wheel, no. So wearing a fit attire, right? That's why you have to wear fit. Can reduce the friction. So now diagram 11 shows a 3 horizontal force act on the car that is moving along a straight level road. So which combination of the force would result in the car moving with constant velocity? Constant velocity means left and right will be the same. Okay. Now, so we see the thrust. Thrust is the force that moving forward, right? So thrust. This is thrust, This is frictional force. And then air resistance. Air resistance also against you. So air resistance here. The direction of they draw it. Oh, they move to the right. Oh, sorry. The driver is driving forward here. So this is a thrust. This is friction. Friction is on the ground, frictional force, and then this is the air resistance. Air resistance, if you don't want to take it as resistance, normally we can call it as air friction. So air friction and air resistance is the same thing. So thrust is 1005. Here 500. Here 1000. So constant velocity, left and right will be the same. 1000 and 500, 1500. So A is correct. A is correct. We look at B. We look at B. Never mind. We look at B. We look at B. Look at B. The thrust is 1005. B here, the air resistance it is 500. So the friction is 500. 500 and 500. So this one will accelerate forward because the thrust is greater than the friction. Right? So B is wrong. We look at C. We look at C. The thrust is 500. So air resistance is 1500. 1500. And here friction it is 1000. So what happened is you pull with 500, but the resistance is greater than the thrust. So what happened to this car? This car will not move. Cannot move. Because the air resistance and the friction is too big. It's more than the thrust. Okay, next one. The thrust is 500. No need to see lah. This two is already bigger. So answer is A. So you do next. Now, diagram 13 shows a method of determine the resultant force of P and Q by using parallelogram method. So parallelogram method, I haven't teach you yet. So I will teach you later at here. Even the thrust, the lift, the drag just now, I'll teach you. Not today. Maybe can. If I do fast, then can. So I'm going to skip this one first. But never mind, I give you the answer first. Alright. So the method, so P to here, Q to here. So parallelogram. So this one go to the right. This one go to the left. So the way you start is you stop at here. So you are going to into this way. So O to Y is your answer. O to Y. Right. But I'll come back to do it again. Right. I'll come back to do it again when I teach you. Diagram 20 shows accelerating in seawater. Now which one is correct? So the drag F2 forward, thrust it is F1. Accelerate. So meaning that you have to go forward. Right? Let's say this one is 1000. So this one maybe it is 200 only. So F1 is more than F2. F1 more than F2. F1 more than F2. F1 more than F2. Answer is B. But if the question said the ferry is stationary or constant velocity, answer is C. Huh? Is that okay? Now the next one. Diagram 17 shows the two forces acting on the object in the opposite direction. Which of the statement it is correct way for the method of calculation between the two forces? F1 minus F2 at minus 6. The direction of resultant force is the magnitude of the in the magnitude without direction of force. A. We look at B. Direction of the resultant force is the direction of the force without magnitude. The resultant force is expressed without giving magnitude and the direction. The magnitude and the resultant force obtained from the vector sum of the two forces. Alright, so answer is D. Right, so from here, very beginning, told you already. So the force represent the vector sum of two or more forces acting on the object. Okay. Alright, next one. Now, that is a lorry moving along the straight road. So which one is constant velocity? Constant velocity, left and right will be the same. So this one is equal to this one plus this one. The thrust, same. Right, 1000. Thrust, 1500. So this one friction and the air resistance is 1500. Answer is D. Just repeat the question. The question it is the same one, just diagram different. Okay. Constant velocity, huh? Now, the diagram 15 shows a horizontal force act on the racing car that is moving along the straight rod. So that is a thrust, air resistance, friction, same. All right. So the thrust is equals to you see uniform velocity. Constant velocity means uniform velocity. Okay. So the thrust 1200, 1200. Air friction 650, 550. 650 plus 550 is 1200. This one plus this one. 550 plus 650 is equals to 120. Right? Not 120, 1200. So A is the answer. Okay? The left and the right will be the same. Equal. So this one 500, wrong. So 1000 only. So what happened to D? What happened to D? If my thrust is 1200, here is 500, here is 500. So what happened? What happened? So 1200 minus 1000. So you still got resultant force 200 going forward. So this object is going to accelerate. Is that okay? It will accelerate. Okay. Now we are going to continue to do this kind of question. Actually, this kind of question, as I told you, you don't need to be too serious into it, because you will learn in your maths, right? And then exam normally they will not ask you to draw, but but I put it into here because I want you to know how. All right, so I'll go quite fast here. Right, in the exam this one is not so important. So by drawing the diagram, the magnitude of the resultant force, how to find? So you pull here, I pull here 15 and 10. Okay, so by drawing, so you have to draw here 15 cm, and then here 10 cm, and then you have to draw here 15 cm, and then you have to draw here 10 cm. This is drawing. They said drawing only. They never say what method. So we normally will use parallelogram method. So parallelogram method, so you start from here and at here. You start from here and at here. There is a other method or not? Yes. Triangle method. I'll teach you later. So now I draw this way. It is easier for you to see. I draw it this way better. This is parallelogram method, Aiyah. Okay, agak-agak lah. No need so soon. So the first one is into this direction, 10 Newton. Here, 15 Newton. 10 Newton. 15 Newton. So my direction will be into this one is going into here. So this one, how much it is, I don't know yet. So I just name it as resultant force. Resultant force, So how to find it? So you need to measure from here to here. So this one 15, this one 10, this one 15, this one 10. You draw it already. The angle 30. Make sure this one is 30. You draw it. Then you can measure this one. Right? So after you measure, you find it is 24.18 cm. So answer will be 24.18. But by calculation, I'm going to show you here. This is 30. Right? Here is 30. So this one 30 mean this one is 30. This one 30 mean this one is 150. Right? So you have learned in maths, right? Cos rule. Cos rule. So this one 150. Opposite square. is equals to 15 square plus 10 square. At max, minus 215 times 10 times cos 150. The formula will be a square is equal to b square plus c square minus 2bc cos a. Do you learn this in MS? I hope you learn it. So never mind. I am going to write it down. F square is equals to 15 square plus 10 square minus 2 times 15 times 10 cos 150. So I'm going to press in the calculator. Right, by calculation, actually they want you to draw one. So in MX they will not ask you this kind of question, cos rule, sine rule. They will not ask you something that hard one. Okay, so this one is 15 square plus 10 square minus 2 times 15 times 10 times cos 150. So you will get 5 at 4.80 at 1 like that. Okay, but this one is resultant for square. So I need to square root. So 24.18. 24.18. Yeah, correct. So answer is 24.18. Unit Newton. Okay. This is called resultant force. Don't leave it like what? Don't leave it like equal to 24.18 because this one is square. So I want without square one. Okay. So this is B. A. This is B. I just want you to know how to calculate. Right. So now C is the one that we want to do. See, so find the acceleration of the object. So we have found the resultant force. Resultant force how much? 24.18, right? 24.18 is equals to MA. M mass is 5 kg. A I don't know. And then they never tell you how much is the frictional force. If they got frictional force, they will tell you, oh, the friction is like 20 Newton, 5 Newton, 4 Newton. They will give you, or they will ask you to find. So this question, they don't give because I said it on my own. I put it on my own. So I don't put it. So you will take it as a smooth surface, no friction. 24.18 divided by 5. So you get 4.836. Unit is ms negative 2. Previously, in physics, you just need to take 2 decimal, but now you better for you to take 3 decimal. Right? Don't take 2 decimal. Take 3 decimal. Right? Previously, the all syllabus, you use 2 decimal will be okay. But now, better for you to take 3. Okay, now the first method that I taught you, it is parallelogram. That now, teacher, just now you said want to teach us about the triangle method, right? Triangle method. So now you start from here, 15. And then you don't start from here again. So you follow. This is called vector, right? Vector method, right? 10. So you join from here to here will be okay, right? So this is your resultant force. You will ask me, Cikgu, what if I start with 10 first? Okay. Now I start with 10 first. From here, I start with 10 first. Don't start from here. Don't go back to here again, 15. No, 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 no. Continue from here, 15. So, this is your resultant force. You can use this one, you can use this one. What if I combine both? I combine both. So you find it is come back to parallelogram. 10, 10, 10, 10, 15, 15, 15, 15, and you go back to here. Like what we had done just now. We go back to do a little bit. They will ask you into this way. Teacher, how to do this? So they said P and Q. Right. So now what I do is I start from P first. Okay, never mind. P first, and then go Q. Right. So you start from here, you work to here, and then you end up with here. So you go from here to here. So OY. How about teacher? I want to start from here. I want to start from OY first. Okay, go ahead. OY. Oh, so Q first. All right, and then P. So you continue to work to here. All right. So the answer still OY. Right. This is the question like what I told you just now. It can come out into this way. So you need to know how to draw it. This is called vector. You're gonna learn in maths also. I don't know whether you have learned it or not. From 4. Vector is from 5, I guess. The sine rule, cos rule, it is from 4, right? From 4. Alright. Okay. Now the next question. So this kind of question. Now, same thing. You draw to here. How to draw? So I use freehand to draw also can. This one they ask you by drawing a diagram. So I draw here 10, here 15. I use parallelogram. Here 10, here 15. I'm not drawing well. Whatever lah. Okay, 请猜啦. So here will be 10. Sorry, here. Here 10. 10. So you start from here, right? You go here, you go here. So you go here, you go here. This one is 15. Here it is 15. So your resultant force will be into this direction. This one is your resultant force. This one is your resultant force. So find the magnitude. Alright. So find the magnitude. So you use cos rule. Right. So this one is 150. Here it is 150. So here it is 150. Mean here it is 30. Mean here it is 30. Right. Here 30. So we use cos rule. Right. Cos rule. Cos rule. So opposite square, resultant force square. Resultant force square is equals to the side, two side square here. 15 square, 10 square. 15 square plus 10 square minus 2 times 15 square plus 10 square minus 2 times 15 times 10 cos back to here, cos back to this angle, cos 30. Okay, so don't forget to label it as 30. If not, actually no need to label also can, because they are asking you to measure one. Never mind, I calculate. So when I calculate, okay, I press here 15 square plus 10 square minus 2 times 15 times 10 cos 30. then square root, you get 8.07. When you draw, you cannot get 8.07. So you agak 8.1 like that. 8.1 Newton by drawing. Okay? But by calculation, it will be more accurate. So F will be your resultant force will be equivalent to I told you, teacher, I don't want to draw. I just calculate and then I even the question asked me draw to get the answer. So you don't want to draw, so you want to calculate, but the answer you write 8.1. You write 8.1 because when the question asks you to draw, so you will not get 8.07 so accurate one. So here you will get 8.1 Newton. Okay. So the direction into this direction. So I want to calculate this angle. Theta. So this one I am going to use sine rule. Sine this one over this one is sine this one over this one. Sine rule. This is cos rule. I better write it down. So sine theta over the opposite it is 10. I write 8.07 because of I want it to be more accurate. Okay. You can write 8.1. The difference will be not that far. 10 move up to here. Sine 30 divide by 8.07 times 10. Because I want to find theta, so I shift sign. 38.28. Right, 38 like that. $38.28. So when you measure, you agak get 38 lah. Okay, you get 38. C, find the acceleration. C, find the acceleration. So acceleration F is equal to ma. F, the resultant force. Resultant force, we have found it already, 8.1. ma, m, 2 kg. A, I don't know. So 8.1 divided by 2, it is 4.05. Unit is ms negative 2. Excuse me. All right. So this is what we learned just now here. See, I said we got 4 methods. Citation 1, citation 2, citation 3, and citation 4. So 1, 2, we do a lot of example, left and right. Right? Left and right, same direction, you plus it. Both go to the left, you plus it. Both go to the right, you plus it. Right? If one left, one right, you minus them. If one go up, one go right, right? Pythagoras theorem. Right? So this one also the same, which is if this direction here, you can draw the parallelogram to do it. So this is the direction. And you can draw the triangle method also. Later we go back to the objective that we had done just now. And then this one also, right? We have done it. So this one is not so important. You can use sine rule and cos rule to do it. So like what we have done just now here, like teacher, this one I don't understand this one how it work. Okay, now here you start from here and then you go to here and then it is from here go to here. Alright, this direction. You start from here, you walk to here, and then you walk to here, continue to walk to here. Is where you start from here, you go to here. Right? You start from here, and then you walk to here, and then salah. So how? So you start from here. Teacher, start from here, and then I walk to here, and then it is from here to here. This one cannot. Teacher, this one I start from here, and then I walk to here, and then this one is here to here. No. Why? Because of this one cannot be your resultant force is shorter than 10. So you start from here, you go to here. So this is Pythagoras theorem. So you have to use this one. So you start from here, here, and then end up at here. Okay? Here, and then salah. Okay, so we move to the next one. As I told you, this year I will teach slightly faster. So the resultant force on the object that is in various state of the motion. So we are going to use the Newton's third law. Newton's third law said that every action there will be a reaction, same magnitude but opposite direction. So of course you ask me, Cikgu, apa itu magnitude? Magnitude, it is a number. Like 5 km, the magnitude 5, magnitude is 5, right? 20 Pascal, so 20 Pascal, 20 is the magnitude, so that's the number, okay? So every action, there will be a reaction at the opposite, with same magnitude but opposite direction. So now, this one you need to know, here. So for the object that is sitting on the table, put in on the floor, got something to support it. So you can see here got something to support here. So an object is put on something that can support. So you must have a reaction. So when you got something, a surface to support it, then you will have a reaction. So you can call it as normal because of it is 90 degree. It is 90 degree. That's why we call it as normal. 90 degree. Always. This normal always 90 degree to the surface. Right? Normal, normal always 90 degree to the surface. You need to know. Must be always 90 degree to the surface. Okay, you need to know. So you can call it normal reaction. You can call it reaction. You can call it normal. Right? Normal reaction will be better. Right? So for the object that is rest, mean it is up and down will be the same. Up and down will be the same. R is equal to W. R is normal or reaction or normal reaction. So W is weight. Weight is always going down. Right? Go to the center of the earth. Now, if I got one object that is hanging on, right? So there must be a tension here. There must be a tension here, right? Tension, hanging, tension. So going down, it is weight. Tension is equal to weight. If it is not moving. Now, of course, you ask me, Cikgu, what if the weight is more than tension? Weight is more than tension, then the object will fall onto the ground. So you cannot calculate. So what is tension is more than weight? Tension is more than weight, then the object will move up. So now when it is at rest, so this kind of question is at rest, must be equilibrium. Okay, so now when the object that is moving moving, right? Moving. So now this object got something to support it, right? So you got weight, you got reaction. If you said you are moving, so the direction of moving is here. Now here you got one forward force. Forward force, we always call it as thrust, right? Thrust is engine punya force, right? Thrust is from engine. So forward thrust and frictional force. Frictional force, I will use this symbol, frictional force. Actually, if you go to Form 6, you will use mu r, the calculation. But no, now no, I just put it as mu, easier for me to tell you, right? You know that is friction. Now, if the object is moved with constant velocity, so or acceleration, so we need to know which one. So r is equal to w. R is equal to w, not moving, right? Or it move with constant velocity. If t is equals to mu, t is equal to mu, mean constant velocity. If acceleration mean t is more than mu, then it is accelerate. Now, teacher, why this one, it is not like constant velocity and acceleration both can? Can. Why? If you acceleration, you move forward, but you are not going up and down. Up and down will be the same. If you move with constant velocity, up and down still the same. But now you move with right with constant velocity, left must be equal to the right. If you are accelerate forward, forward force must be more than the frictional force. Forward force, T, must be more than the mu, so that you can accelerate. Okay. Now, if the surface is come into this way, right? So this one I will go into detail again. Not today, but you just agak know lah. For the object that is moving constant velocity or acceleration, so r is equal to w cos theta. So w cos theta. So where is the cos theta? So here, this is your theta. Right? You need to know how to draw. So draw this. This one is your theta. This angle always same as this angle. So now this is r reaction. Now reaction always 90 degree to the surface, right? You know, so cannot like that. You cannot draw like that. Teacher, weight going down, reaction going up. No, reaction is 90 degree to the surface. 90 degree to the surface, right? Now the second thing is the component weight down the plane. So that is a weight down the plane. Right? Component weight down the plane, it is W sine theta. Right? But it is not going to go into detail today. Why it is sine theta, why it is cos theta, I will tell you in the future. Right? Okay. Now here. And then here. This angle, why it is theta, I can tell you. Right? So why this angle is theta? Let's say this is 30. Let's say lah. Right, 30. So there is an object going down. So this one must be 90 degree. I told you 90 degree. Right, 90 degree. So this one is 90 degree, right? 30, 90. Here gonna be 60. Here it is 90. 90 minus 60. Here gonna be 30. So when here 30, here 30. No need to see. Here theta, here theta. No need to see. Must be the same. You don't agree, right? You don't agree, never mind. You try. 20, okay? Teacher, you purposely put 30. It is the same. Okay, never mind. So here, this theta, I don't know how much. So this is 20, this is 90. Right? 180 minus 90 minus 20 mean 180 minus 90 left 90. 90 minus 20 left 70. So this is 90. 90 minus 70, here is 20. Mean here 20, here 20. Here 30, here 30. Here 70, here 70. Here theta, here theta. No need to see. Must be the same one. Must be. Always the same one. Okay. So the next one is for the object that is not hanging, not putting on the floor. So you got one force going up. It is called lift. One force going down. It is called weight. This is drag. Drag is air resistant. And then forward thrust. Forward thrust engine punya force. If the object move with constant velocity at constant height, up and down will be the same. W is equal to L. And T will equal to G. T is equal to G. Because constant velocity, left and right same. Up and down, it is the same. What if the object is accelerating but also increase in altitude, right? Accelerating means forward is more than drag. So T is more than G. T is more than G. T is more than G. If you said increasing altitude, up is more than down. Because you increasing, up is stronger. L is more than W. If you said accelerate with constant height, constant altitude, so L will be equal to W. Alright, this is what we have. Okay. Let's try some questions from here. Label all the force acting on the stationary object and then find the normal reaction for the object. So this one will be easy. So we start from very easy one first. So this is called weight. So this one is called reaction. This is called weight. The going down, it is called weight. Go up, it is called reaction. Okay. So now find the reaction. So this object up and or down, not going up, not going down. So R is equals to W. W is equal to mg. M how much? How much is M? M is 5 kg. G is 9.81. So you get 49.05. You press calculator, you get 49.05. You need Newton. Okay, I repeat one more time. The force that going up and down will be the same. Why? Because the object is not moving here. Right? You put on the table, how can it move? Right? So it is when it is not moving, W is equal to R. Okay. Now the second one, right? The direction of the motion, it is going to the right. This is rough surface. Label all the forces acting on the object. Okay, so here, this is called weight. This is your normal reaction. So this is W, this is R. So because of this one got moved, this one not moving, this one move. You see direction of motion. So now here got thrust. Here got drag, or you got friction. Here it is friction. Right, friction, normally I will like draw mu lah, but here I cannot. Never mind, I draw. So this one is thrust. Thrust normally I use T. Right? So this one normally I use mu. Right? So depend on the teacher. Some of the teacher like they like to write into this way. Also can. Right? Friction. Frictional force. Okay? So if you don't want, you just leave it as mu. Also can. I can do it this way faster. Okay? So find the normal reaction of the object. So I don't care up. I don't care. Because of, I don't care whether this one move left or right. How fast it is. So this one, it is not going to go up, right? So up and down will be the same. Up and down will be the same. So when up and down, it is the same. R is equal to W. W is equal to mg. Mg, M is 2. G is 9.81. 2 times 9.81, it is 19.62. Unit Newton. This one easy, press calculator one. I don't need to show you already. You are on fire already. Don't tell me you don't know how to press calculator. Alright. And B. The trolley is pulled with the force 12 Newton and the frictional force is 3. Okay. This is 3. This is 12, alright? So find the acceleration. So B, find the acceleration. How are we going to do that? We are going to use F is equal to ma. Newton's second law. F is equal to ma. This is Newton's second law. M, mass of the object, it is 2. A, acceleration, I don't know. They asked me about the acceleration. So what is my resultant force? Resultant force, you pull with 12, right? But you got a friction 3. So 12 minus 3. 12 minus 3, it is 9. 9 divided by 2, it is 4.5. A is equal to 4.5. MS negative 2. Okay. Is that okay? I hope you're okay. Now, we continue to see this kind of question. Example number 14. Find the acceleration of trolley if the frictional force, it is 5. Alright. So, I am going to draw here 5. Frictional force 5. Okay. Here, 5 Newton. So, 20 minus 5 is your resultant force. Okay. So, F is equal to ma. Your resultant force is 20 minus 5. is equal to ma. M, 2. So, 15 divided 2, A is 7.5. Right? A is equal to 7.5. Now, next one. Find the frictional force at the rough surface. Right? If it is moving with the acceleration 2. Now, previously, all we do is constant velocity. But now, it is not constant velocity. Alright? So, you need to be very, very careful. So, F is equal to ma. F, your net force. 20 minus the friction. Friction is... don't know. Right? Friction, I don't know. So, 20 minus the friction. I don't know. Right? I put my friction as F. This is ma. M, 3. A, 2. 3 times 2. So here 6. 6 move to here become minus 20 minus 6. So F move to here. F is 14. 20 minus 6. Whereas, where is the F? This one is your F. This one is your friction. This one is your friction. Right, friction. 20 minus F. 20 minus F is equal to ma. Okay. We continue from here. Find the frictional force of the trolley when it moves with constant velocity 2. So constant velocity no need to do 15. Frictional force 15. So frictional force is equal to 15. Or if you want, you can say 15 minus friction is equal to ma. Your a is 0. You move it, you get it. We do 2 times already just now. Okay. Now you pull with F. Here you got friction. 2 kg trolley, pull with the F, and then it move with constant velocity 0.5. So I don't care how much is your constant velocity. I don't care. So this question indirectly telling me how much is the frictional force. Frictional force is equals to F. I pull with F. I pull with F. Then you move with constant velocity. I pull with F. You move with constant velocity. Now the force is double right now. The force is double. It will accelerate with 2. So F is equal to ma. F. F is equal to ma. What is your F? F is double. 2F. Minus the frictional force. Your frictional force is F, right? Is equal to ma. M, 2, A, 2. So 2F minus F left F. F is 4 Newton. I repeat one more time. You pull with a force, then you move with constant velocity. So how much is your frictional force? Or you pull with force. You pull with F, your frictional force will be the same, right? Because constant velocity, right? Now you double, so 2F, you pull. And then you minus the frictional force, the same one. You are going to accelerate with 2. MA, 2A, 2. So 2F minus F left F. So this is how we do it. Okay. This kind of question I cannot I cannot too much. This kind of question I will leave it as next week lah. Alright. So before I end the class, alright, I'll tell you, I am offering all Form 4, Form 5 tuition for free for February and March. So if your friend want to join, you can send the Google form to them, right? The Google form I already put in the comment there. You can send the Google form, or you can forward the video to them, right? And then if they join after March, so we need registration fee, so they need to pay extra. Now you join, no need to pay anything, and then you got free notes. I don't know why you don't want to join, right? If your friend want to join, ask them to join right now, fast, right? And then thanks for the class today. Thanks for the attention today. And then if you can, you help me to click that like button, right? That's all for today. So I'll see you again. Now, for the student that they want to join Mandarin class will be Mandarin physics will be on Thursday. If you cannot, teacher, my timetable is crushed with others. So never mind, you can watch a replay. Even you join, you can watch a replay later. Alright. So thanks for the attention today. So I'll see you again. Bye bye. Bye bye.